All right. Welcome again. If you haven't attended a webinar or watched one of the videos before, I'm Dr. John Lohr in the Science Olympiad National Office, and I'm excited to bring this presentation for you tonight. We got a great speaker, Karen Emmons, our Physics Committee Chair and longtime National Event Supervisor. She's done a number of national workshops for us, is here tonight to talk to you about Hovercraft. And I know she's got a really packed agenda, so I'm going to get to her in just 1 second. But I want to remind you guys of three things. One, this video is being recorded, or the session is being recorded. Everyone will get links to the recording later this week, and it's going to go up on our YouTube channel, Science Olympiad TV, so you can watch it there without having to worry about using Zoom. Second thing, if you have a question for Karen, please use the Q&A feature of Zoom. It's to the center right of the Zoom toolbar. It's the little box with the question mark in it. Type it in there. We're going to try and answer as many questions as we can. Karen's plan is she's built a couple of key spots into the presentation where she's going to take a break, and that's when she'll go ahead and try and tackle some questions. Last but not least, if you have any questions about, hey, you think the video might have froze, or there's an audio issue and you're not sure if it's us or it's on your end, that kind of stuff, feel free to please put that in the chat. And that's where we'll keep an eye on it. Do not use the chat for questions, simply because it's just the chat's not designed to track questions easy. And I know we're going to probably have a few tonight for Hovercraft. So, without further ado, please help me welcome Karen Emmons to present, or Karen Emmons tonight to present for you.
Thank you, John. I'm delighted to be here. I believe I'm sharing my screen. Can everybody see? Is that viewable, John?
Yep, you're looking good.
All righty, then we'll go ahead and we'll get started. So this is my agenda. I'm going to talk about all of that today. We're going to start with an overview of the event and then take a dive into all of these topics on construction. I have a lot of material to share, so I'll pause for a question at three junctures, right after the overview, after choosing motors and batteries, and then, of course, at the end. So it will help me if you tried to keep your questions about what we just talked about. So let's start with the overview. In Hovercraft, teams design, construct, and calibrate a self-propelled, air-levitated vehicle that moves down a track. Now, the Physics Committee has made a number of improvements to the event since the last time it was run years ago. We removed the written test. We figured constructing a hovercraft is enough work. We added a distance score so that the hovercraft scores points even if it doesn't make it all the way to the finish. And I particularly like that change because before the hovercraft had to make it all the way to the finish to score. We added the possibility of using a ramp for hovercraft that have trouble getting off the start, thus helping hovercraft get some distance score. We standardized the track between B and C, so one track can be shared, and that was an effort to help tournaments. And we removed the log as a scoring element, although we obviously still highly recommend calibrating your device and impounding notes. So how is the event scored now? It's three components. There is a distance score, and that's essentially just how far down the track it travels. Full points if the hovercraft crosses the finish line. So if it gets halfway down, it gets half the points. There's a time score. That's up to 60 points. And that's how close to the target time that it takes the hovercraft to cross the finish line. And if the hovercraft's dowel does not cross the finish line, that's 0 points. And then there's a bonus score, and that's an opportunity to earn 15 extra points, or up to 15 extra points, after the first complete run, and it would be by attempting a new bonus target time. So a few things about the event time. It is an impound event. Teams are given the target time at the start of their competition time. They'll be told the bonus target time if they become eligible for it. Teams get 8 minutes of track time to complete runs. Time stops for ES measurements of distance or to record time. And teams can fix safety and construction violations during that time, but they don't get any additional track time. Now, I've been noticing that there's a lot of confusion about the number of runs. Kids sit down and they go, how many runs do I get? Well, the short answer is at least 2, never more than 4, but it depends on what happens. So if you have 3 incomplete runs, that stops the team's competition time. And in the vernacular, an incomplete run means the hovercraft didn't get all the way to the finish line. And that is noted by either the hovercraft failing to move for 3 seconds and getting stopped, or the hovercraft does not cross the finish line within 2 times the target time. A team may not declare a run incomplete. The ES does it based on those 2 criteria. And teams get a distance score for such runs, though. And just as a by the way, it's not a run if the dial of the hovercraft never crosses the start line. So then what happens if there's a complete run? Well, a run is complete if it's not complete. In other words, the hovercraft does make it to the end. In that case, then the hovercraft gets the distance score and a time score. Now, once a team has 1 complete run, they're allowed only 1 more run, the final run. It doesn't matter if the team has more incomplete runs that they haven't used up. So let's say a team has 2 incomplete runs and then has a complete run, they get 1 more, the final run. Or let's say on their very first run, the team gets a complete run. They get 1 more, the final run. If they have 3 incomplete runs before a complete run ever happens, that stops and they never have a complete run. Now, what happens with the final run can go one of 2 ways, depending on the complete run. If the complete run has a run time within 25% of the target time, the team has a decision to make on the final run. They can either try to improve their run score, thus foregoing trying for the bonus, or they can stand pat on their run score, keep it, and then try for additional points with the bonus with a new target time. If you ever competed in or were familiar with air trajectory, it's a little bit like that, where the first shot was at the table, and if it was close enough, you could either take a second shot at the table or you could try for a bucket shot. Kind of that thinking. But I would like to encourage teams to think about whether they actually really want to go for the bonus. In the excitement of being told that you're eligible to try for the bonus, it's not, you need to actually take a step back and think about it. It isn't always obvious that teams should go for the bonus, even if they are eligible. It's a decision-making process after the complete run and is very dependent on how well a team knows their hovercraft. So what you're looking at now on this screen are excerpts from 2 spreadsheets that I made for myself. No special knowledge to make these. You can make these too. It comes straight out of the scoring formulas in the rules. So the one on the left is what you would score at certain target times if I had a run time of 8, 9, 10, 11, 12 seconds. So in this make-believe tournament, the target time's 12 seconds. And then if I had a run time of that, a complete run time, I would get 45 points. Now I have a dark rectangle around the parts of that column that show that I would be eligible for the bonus. 9 to 15 seconds is within 25% of the target time, 12. So I fell in the range. I can decide on my final run that I want to keep that 45 points and try for an additional points in the bonus run. Or I can decide I don't want to and I want to improve my score. And really, it depends on how my hovercraft works, right? If my hovercraft has really very little speed control and it just pretty consistently gets down to the end of the track in 9 seconds, I'm probably not going to improve on my target, on my run time, but so I could keep my 45 points. And if you go over to the bonus spreadsheet and the bonus time is 16 seconds, say, well, then I would get 5.2 for a run of that. So I could get 45 plus 5.2. But let's say I do have some control. And maybe I can't make it all the way to 16 seconds, but maybe I can make it to 11 or 12 with just some adjustments. Well, remember that the target time, the time score is up to 60 points, and I'm 15 points from that now. Let's say I'm pretty confident I could get my hovercraft to go at 11 seconds. Well, if I take another try at the same run time or at the same target time, I could get 10 more points for that and get a score of 55. But if I did 11 points on the 16-point bonus target time, I'd only get 8 points for that. So it actually would behoove me to not go for the bonus. So there are trade-offs here, and I encourage teams that want to be competitive to create these spreadsheets for themselves and just print them out and think about their hovercraft and think about how it works. Now, I know I went through that pretty fast, but I encourage you to play with the numbers and see what I mean. Two more things that I want to talk about in the overview. You don't need to make an impressive track for practice. You just need a flat, smooth floor, a straight 8-foot long item, which could be like a 2x4, or even an 8-foot table turned on its side. You place that item 45 centimeters away from the wall, tape out a start and a finish line on the floor with masking tape, and voila, you have a down and dirty track. Now, there are plans on the national site to build more tournament-worthy tracks, but I also encourage you to remember that you don't need to have a built-in floor on the track. The rules do not require that. The event can be run on a gym or a linoleum floor. So practicing in that kind of situation is very akin to what you may encounter at a tournament. If you do have a floor on your track, if you do build a floor on your track, you're going to want it to be akin to something as smooth as a gym floor, linoleum floor. People tend to like melamine for that. And finally, I'd like to say a word about the ES-provided ramp. Don't design for it. It's a backup. I was judging hovercraft last weekend, and I had kids come in, and they're like, "Where's the ramp? Where's the ramp?" That's the ramp? I think that they were expecting it to be a ramp like a gravity vehicle ramp. It's not tall. The picture of it here is beside a D battery. It's just designed to give a little help if the hovercraft is having trouble getting off the start. So, and teams take a penalty. They take a 50% penalty on their distance score if they use the ramp. So my suggestion for you is that you don't come in nervous and thinking you have to use the ramp. My suggestion is you strongly lean toward doing your first run without the ramp. The worst that will happen is you'll use up one of your three. You have 3 incomplete runs. But if it turns out to be a complete run and you use the ramp, you probably didn't need it and you'll have incurred the 50% penalty. So it's there if you need it, and it has had impact. I have seen teams get off the start that weren't able to, but it's just a backup. Now, for those of you running tournaments or event supervisors, we do have to provide the ramp at tournament, and I did want to make a note that Wards is selling the ramp for a very nice version of the ramp if you'd like to do that. All right, I'm at my construction section now, so I said I'd take a break and read some questions. Let's see. Okay, I'm going to skip the integrated circuits one. That's for later in construction. Will you earn more than 15 points if you attempt a bonus run and get a higher score? No, you are committing. After you have a complete run, the ES will show you the bonus target time. You can take a minute, think, do you want to do the bonus run or not? And then you get a new target time, and you are committed to either doing the bonus run or just improving your time, and you'll have to claim that right up front. What happens if you do badly on the bonus run? Nothing. You get your base score, which is why we wanted to make sure you were within close enough that you'd at least get 45 points on the time scoring component of it. If you do a bad on the bonus run, do your points get deducted? No, not at all. It's just, you just would get a 0 on the bonus run. And there's no distance score in the bonus run. It's only for the time. When you saw flat, does that mean, when you saw flat, does that mean checked using level as flat as most floors. Okay, I think somebody is asking, I'm having a little trouble reading that question. I think people are worried about whether floors have slope, or whether they're flat. I carry a level determinants and I try to find a spot in the floor that looks good and level. Does the distance change or is the distance constant, just the time changes? Yes, the distance is constant, and it's laid out in the track description in the rules in that section. That does not change at all this season. It's just the time. And the time interval is different between B and C. For B, it's I think 10 to 20 seconds. For C, it's 6 to 26. If you get lower points when you reattempt the run, do you take the higher score or the most recent? It's the higher score. Absolutely. If the device hits the side and stops and hits or reach the end slow, is that considered incomplete? If it hits the side but continues on, it's okay. That's not one of the parameters for deciding the run is incomplete. The hovercraft has to be stopped for 3 seconds, or it takes more than 2 times the target time to get down to the end. Let's see. If you qualify, do you get time between the final bonus to adjust the speed? That would be part of your 8 minutes. Maybe I'm getting to this later, but the rules recommend using a photo gate system. Is there one I recommend? I'm sorry, I don't know the whole wealth of photo gate systems, but you could use 3 manual timers too, and just have just use the laser beam. You can get a quite solid. If I'm sorry, your photo gate system isn't working for you, but having a laser with a dowel that interrupts it could do quite good timing for 3 manual timers as well too. Sometimes competition tracks aren't flat and have a slight dip or slope. What should a competitor do then? The best they can. I mean, that is a fact of life in events that are run on floors. But as I said, I personally, when I run an event, I check it out ahead of time. I take a level with me and I look for a very smooth level, or actually sometimes I aim it downhill a little bit if it's slopey. So I try to find as quality an area to run in the area that I'm given as possible. Worried about friction. You saw a post about an invitational where Hovercraft did poorly because it was run on plywood. Plywood is not terribly smooth as a track floor. That's why I'd actually rather run it on linoleum or a gym floor. I'm a national event supervisor, I think in B. I haven't received my invitation yet, but I've been told it would be B. Our tracks don't have a floor. If you're in B and you're at nationals, you're going to see our tracks being run on the whatever floor they give us at nationals. For a long time target, the hovercraft will barely be moving. Could this cause problems? Yes, that is one of the challenges of the event. And we're going to talk about time control. Is there a minimum height of the side panel? Will you be able to split up your 8 minutes so you can tweak it after runs? So the time starts as you start at the track, and then the event supervisor turns the time off to take measurements and whatnot, but then turns it back on as you are doing your own calculations or your thinking. So I'm not totally sure what you're meaning by splitting up and tweaking runs, but you utilize that 8 minutes as you need it. The hovercraft is under 40 centimeters before the start when the skirt inflates in size. Okay, now that's a construction question. I'm going to answer that later. Will the event be on a floor or on a table? I wouldn't run it. If I were going to run it on a table, tables. I don't know if there's a long enough table that wouldn't have, that wouldn't be like one of these bendy tables that has a break in it. So, but you're going to have to ask at whatever tournaments you're going to. I don't run on tables. I run on floors. Why does our team's hovercraft? Oh, wow, run in circles. We're going to talk about that. Okay. Is the flooring run on the floor on a shiny, smooth table? As I say, I ask for a nice linoleum floor or gym floor. Okay, I think I've covered, yes, everything else is about construction, it looks like. What if you don't have time to do a final run? What if you don't have time to tweak it before the bonus? Well, I would encourage you to practice and understand how to work with your hovercraft efficiently. Because 8 minutes is actually quite a long time to do these runs. I haven't seen people running out of time typically. So the more you practice with it, the more efficient you'll be able to be with your track time. All right, let's move on to construction. So those are some pictures of my co-judge, Ian Emmons, and I building our own hovercraft for this season. We've had an interesting time and we've learned a lot doing this. To go back to my slides. Here we go. All right. Well, I can't start any discussion of construction without starting with the safety parameters because there are 3 rules that failure to observe them means that the vehicle isn't even allowed to run. So I'm going to call them out here. The first one, 3C, all propellers, including any propeller under the vehicle, must have shielding that prevents a 3/8-inch dowel from touching them. There's rule 3D that says it has to be commercial labeled batteries, not exceeding 12 volt on a circuit, no other energy sources, no lithium or lead. And rule 3E is all motors must have a switch. So you can't just twist wires together to start the hovercraft. You can't plug the batteries in. It actually has to be a switch. Now, the most common one that people miss here is 3C, is the proper shielding of the impellers. When I judge this, I take my dowel, I poke around. I don't dig in there. I'm not trying to be unfair. I'm not digging in there like I'm searching for gold, but if I can touch it easily, it's a no-go. On the bottom, and again, that's the one that most people miss, if your skirt covers the fan output underneath, that's also okay. But if there's a big slit, if I can get my dowel in there, then that's not going to be okay, and I have to make the difficult call. So please, please pay attention to the safety parameters. It's devastating for everybody to have to make this call. In addition, moving on, just in construction, in the ready-to-run configuration and levitated, it has to fit in a 40-centimeter cubed box. It has to levitate. There are limited electrical components. And when levitated, the dowel has to be within the first 3 centimeters of its front edge so that the top end of the dowel is at least 20 centimeters tall. Be careful. This trips several people up because when levitated, sometimes people's skirts balloon out the front, and thus that makes the dowel further from the front than when they measured it with it off. So make sure you're assessing that as it's levitated. Somebody asked a question, if the hovercraft is under 40 centimeters before the start, when the skirt inflates and the size goes over 40 centimeters, will it be allowed? We'll allow it to run, but it will take the construction ding because we're measuring the 40 centimeters in the ready to run configuration and levitated. So if your skirt inflates out, then the hovercraft is too big. We're going to talk about skirts in a little bit. They don't need to be that balloony. All right. All right, so let's keep moving on. A common question. People are really fretting about it. The common question is it levitating? Well, we're not looking for an Aladdin flying carpet here. It isn't expected to be measurable by a ruler. The touch test with the hovering motor turned on, teams push it down and it should pop back up. And some part of the vehicle in the skirt may still be in contact with the ground. That's true on hovercrafts that people ride. In fact, with bubble skirts, which we'll talk about later, in fact, we'll always have some drag on the ground. But But it does need to come up. It does need to reduce its friction. That's come up. It does need to reduce its friction. That's what you're really looking for in this, that there's an airflow that reduces the friction. A lot of the times I find when I'm judging this, I don't even really have to make the team go through the push down test, because when the hover motor's turned on, the vehicle will rise up and it'll skitter, because all of a sudden the friction is greatly reduced and you know immediately that it's got that kind of a hover. So I know people are fretting, does it need to be a centimeter, 2 centimeters? No, we're not looking for a flying carpet. All right. There's a list of allowed electrical components. Let me try that word again. Electrical components in Rule 3F. And we mean it. All right. So batteries, battery holders are okay. Wires, manually operated switches, resistors, potentiometers and rheostats, capacitors, and up to 2 motors. So the integrated circuit question. We are allowing brushless motors. That is new in this iteration of Hovercraft, but because they're so common and so available now, but no integrated circuits unless they are an integral part of the commercial motor. In other words, manufactured as part of it. So no separate electric speed controllers or pulse width modulation. If there should not be any kind of integrated circuit that we can see on the Hovercraft. But let me assure you, please, there are many, many, many extraordinarily reasonably priced motors and fans that are built with these included. So you don't need this kind of these kinds of controls to do this. So where do you start as a newbie? Your big purchases in this event are your motor, your blower, and a battery. Now, when I say motor, blower, motor, fan, blower, they're all sort of interchangeable words in this context, all right? Now, the Hovercraft, so the first question you're asking yourself is 1 motor or 2? The Hovercraft has to both lift up and move forward. And as I said, you're allowed 2 motors. Now, I've seen designs and kits with only 1 motor, where the air comes out of that 1 motor and it's directed in 2 ways. That is doable. But I'm going to be honest, I think that's very tricky to do well, very, very difficult. If you're a newbie, I would encourage 2 motors, a lift motor and one to push it down the track. So then you come to the question of 1 circuit or 2. A circuit, is a network of connected components. And you can have one 12-volt battery on 1 circuit that's 1 motor, and you can have one 12-volt battery on a circuit that is another, but for your other motor. You can do it that way. 1 battery can support 2 motors, and it's a lot less weight on the Hovercraft. So there's a trade-off there. And the one we built, we're powering 2 motors off of 1 battery. But I want to talk about just briefly understanding when the word battery is used in the rules. There's a difference between batteries and cells. So as I said, there's 12 volts per circuit, and a cell is a single fundamental power producing unit, like a standard AA or AAA battery is technically, we call it a battery, but it's a single cell because of its chemistry. It always produces that amount. A battery is an assembly of these wired in series or parallel to increase voltage or current. So you can't get 3 9-volt batteries and put them in series and say, but every one of these batteries is below 12 volts. You're looking at the entire voltage on the circuit. So understand that difference. And if it's a little unclear to you and understanding about series and parallel circuits, this is a circuit lab year. So coordinate with your circuit lab people that are on the event and have them explain some of this to you and work with you. This is an event where you have to think about your power budget. And there's 2 biggies on this. Your power supply voltage output needs to be equivalent to the hardware voltage demands. So 12 volts backs on the circuit. Look at the demands, particularly on from your motor. You don't want too high or too low a wrong match there. Now you can have a 9-volt power, a 12-volt motor. Often, not always. It depends on the motor. So look at your components, read about your components, look at spec sheets. But you can also kind of tell by just looking at your hovercraft, right? If you smell your components burning, there's a problem. If your batteries are getting hot, there's a problem. In fact, the first thrust motor we tried said it was rated for 12 volts. We plugged it into our 12-volt battery and we could smell it immediately. It clearly wasn't really rated for 12 volts. And then your power supply current or power, I mean, those are equivalent statements. The battery output must be higher than what your motor consumes. So there needs to be more power coming out of your battery than your motor consumes. Choosing motors. So motors, I think, come in primarily two types. There's blower motors and axial fans. Now, a blower motor is the one that's in that upper right, and then the axial fan is in the bottom, at the bottom of the slide. And you can see the difference about where the intake is and the outlet is for the air on these. So you're looking for something for lift and something for thrust. Well, there's two very common measurements of how powerful a motor or a fan is. And one of them is static pressure. And then there's also airflow, which is measured in CFM, which stands for cubic feet per minute. Which do you want? Well, high static pressure fans, they're better for moving air through restrictive spaces. That should be screaming skirt at you. They're really good for lift. But your high CFM fans, they're better for moving large volumes of air in open spaces. And think about that. You're in a big open space and you've got to move that hovercraft down. Think thrust for that. Now you can use both for both. And I've seen a lot of hovercraft use an axial fan for both the lift and for the thrust. But I will say, if you're worried about your power budget, like we were watching carefully because we wanted to only use one battery, kind of for expense and also for weight. The blower motors in typical utilize a lot less power for the same static pressure. So what's enough static pressure? And I call out to Andy Ham for sharing his methodology here with me. And I'm not worrying about significant figures here. So it really depends on the area and the weight of your hovercraft. So for ours, our hovercraft is, there's the area of our hovercraft. I just measured it. And then I took our hovercraft with all the expected components, our battery and the switches we were going to put on and the motors, flopped it on a scale. It measured about 450 grams, which is 4.41 newtons. And I had to look it up on Google to convert it. I know you can too. And then you take the weight in meters, the weight in newtons and divide it by the area in meters squared, and you get how many pascals you need. And we needed 131 pascals. Our lift fan, so when we got on and we were looking on DigiKey, you can also look on Amazon, though I will tell you that like on DigiKey and some of those other sites, the spec sheets are a little clearer. You can't always tell what you're getting on Amazon. Our lift fan has a static pressure of 167 pascals. Now, you can find fans with way more static pressure than that, but we didn't want it to draw too much power. And it hit the sweet spot for us. It's working great. It's levitating. Now, I don't have a similar slide for evaluating perfectly a thrust fan. The formulas for that are all about trying to air condition a room, and it's just a harder call to figure out what you need, I'll be honest. But like if you are levitating really well, you need less thrust too, right? You're going to have less drag. So there's some components of that as well too. We had a couple of the fans just sort of sitting around from old, like little electronics kits. And we stared at them and we thought, well, which of these should we use? Which one's better? Because we didn't have spec sheets, they were in old kits. And actually, I think my partner came up with a great idea for how to measure which fan's better if you have to. So we plugged them in, turned them on, and put them beside a scale to see how much force they were generating using that. So that was a nice way of comparing fans. But I don't have a perfect way of choosing your axial, choosing your thrust fan. Choosing a battery. One battery or two, we've already had that discussion, and it's weight versus power capacity, really. But I highly, highly recommend rechargeable. You're going to go through a lot of batteries as you figure out how your hovercraft works, what you need to do with it. I think rechargeable is the way to go. For us, our single largest expenditure in building a hovercraft was buying a battery and the recharger because we didn't own a recharger. And a lot of people out there already have that. So if you have that, that's the big expense that I found. I suggest battery packs. And remember how I was talking about the difference between a cell and a battery pack? Now you could use like a 9 volt but you could also create a cell that's like 8 AA's. And by doing that, you typically increase the total capacity and runtime of your battery. It can deliver higher current, it allowing the powering of higher demand. It minimizes voltage sag typically. So that can be a good way to go. And you can also buy already shrink wrapped, like intended for RC car 12-volt battery packs like that too. But you don't have to go that route. You could do it your own way, just as I said too. You cannot use lithium batteries. Alkaline batteries work fine. If you are greatly mourning the loss of the lithium batteries, nickel metal hydride batteries are a very good substitute. All right, that's where I'm going to stop again, and I'm going to check some questions. Let's see what we got here in the Q&A. Hovercraft running in circles, I'm going to talk about that in a bit. In the case of a vertical fan where the fan is not opening to the bottom, do you need to protect the bottom with a fan grill? If you don't have fan blowing at the bottom, I'm not totally sure how your hovercraft is hovering. Unless the fan is blowing air out and then you're directing it down. So you can do the same test we do. Buy yourself a dowel and poke around. And if you cannot touch the propeller, the impellers of your fans, then you're good. That's exactly what we do. It's simply that. You can try it yourself. Does the shielding from Rule 3C need to cover the entire propeller impeller, including the wires? No, it does not need to cover the wires. It needs to cover that rotating part. And it really is a safety issue. There have been, years ago, there were some problems about it when we didn't have that rule. It's really important. Those fans, you don't want your fingers near that. Does the fan shielding need to be stiff? You're using bird netting for shielding. I can't really judge that. I don't know what bird netting is. I'm sorry. No, not perfectly. It just needs to keep my fingers out of it, and my pokey dowel. So it might be okay, but I'm not sure, and it's very hard for me to make a judgment call on that without seeing it. What is really a dowel? Can you show one in one of the images? Oh, I'm going to go back to some pictures of my hovercraft, which is not terribly exciting, but it has a dowel on it. So if you look right here in the one, this is our completed hovercraft. That is a dowel. It's like a small wooden stick. It looks, whoops, sorry about that. Looks a little bit like a pencil. And you can buy them at a hobby store or whatever. So that's what a dowel is. All right, let's see what else we've got. See if you do have a slit underneath the skirt and you provide a safety cover for the fan as well. Is that allowed? Absolutely. More power to you. Can I create an air cushion with no skirt? Going to talk about skirts in a minute. I presume 40 centimeter cube box means 40 by 40 by 40. I think that's a typo. It's yes, 40 centimeters by 40 centimeters by 40 centimeters. What about transistors? Are they allowed? No, they're not on the allowed list of components. Let's say I have a fan that is under the hovercraft. Could I use masking tape for the shielding? Yeah, you could try that. Masking tape is going to block a lot of airflow. It feels like you would want some kind of netting, and I'll talk about shielding in a minute. But again, if you're looking at my hovercraft, you could see like I just bought a little bit of, it's very open, that netting, so that the airflow is much better. How come my 9-volt batteries are used up so quickly? It depends on your components and your motor. I don't know, but this is why I would encourage rechargeables. Then you'll at least not have to keep spending on 9 volts. Is 12-volt limit measured using a voltmeter or based on the battery rating? It is not measured using a voltmeter. It's measured based on the commercial markings on the batteries and the ES, looking to see how they are wired together. So this is why we require the commercial markings be on the batteries. What if you choose a bad motor? All right, I bought my motor for $10. So if you think your motor's terrible, I would, if you can, I would encourage you to work around it or think creatively about what components you're using and see if you can lighten the weight. I don't know where's the best place to buy fans. I bought one fan on Amazon. I bought one fan on DigiKey. There's Adafruit too. Those are the 3 places I go. Is the area in the vertical base or just the, I'm sorry, I'm not sure. The area in the formula for the static pressure, is that just the air outlet? No, it's the area of the entire, the surface area of the entire hovercraft. Can a custom-built battery be used, or does it have to be? No, it must be commercially labeled. What type of motor would you say is overall better in your opinion? Well, I've talked about the 2 types. There are many out there, and there are many great ones for very reasonable prices. And I've talked about how to evaluate. So I think that that's the best way going there. How do we even start building a hovercraft? Is there some documentation? Where do we look for theory to understand how to build one? Well, I'm trying to go through that now, at least talking about the important components, and now we're going to talk about some of the other stuff in a few minutes, like skirts and whatnot. But first thing you need is a base, right? And you can see the base on my hovercraft is the top of a takeout container. So you can also, and I've used cardboard and, some things like that too. So there are also good resources on Scioli. Let's see. What's the difference between volts, amps, and watts? I would encourage you, that's a Circuit Lab question, and I don't think I have enough time to discuss that tonight, but talk to your Circuit Lab people or look at some of the Circuit Lab resources on the national website. There are great introductory resources on circuits there. When you calculate how much pascals for a blower fan, is the volume of the skirt important? Maybe. I'm not sure. You need your blower fan to have better static pressure than what you calculate, because there's going to be air loss. And it's probably, I don't know if it's about, the volume is sort of indicative. The surface area is kind of a stand-in for volume. I think a bigger deal has to do with leakage or how well your skirt is built. We'll talk about skirts in a minute. Can we change the batteries in the second, third run? You can change the batteries as often as you want. That's part of your 8 minutes, and I would encourage you to bring backup batteries. Can I use any method or mechanism to avoid or reduce contact with the walls? That's a very large question. Any is a very big question, so I'm not sure how to answer that. We're going to talk about avoiding the walls in a minute. When connecting wires, do you know of any safer options than soldering? Yes, there are. Well, soldering is not that hard to learn, but there are all kinds of connectors. Google non-soldering connectors. There are some that you can almost sort of shrink wrap with heat. You can use, we're going to talk about that in a little bit further down the line. Our hovercraft is levitating, but it's not going forward when I add one single 12-volt battery. I'm sorry, keep working on it. I'm not sure if you mean you're using both motors with one battery. Maybe, yeah, it depends on, that's too big a question. I'm not sure I can answer that. Talk to your circuit people, see if maybe you need to rewire. Is the switch on the fan? The switch can be anywhere. In my particular hovercraft, they're actually sitting over here. They're just loose switches, not on the fan at all. We encountered a fan type that had a current limiter built in. We couldn't get it to stay on. Okay. All right. Hello, when we put the fan, which isn't a blower fan, it is a fan which takes the input and outputs on the air on the other side. It isn't moving forward. We tried lightening the weight, but that didn't work. Do I have a solution to the problem? Again, this is going to depend on the components. So you're talking about the thrust. How's the lift, right? You might need a better skirt. I was amazed by how much the skirt made a difference, for example, when I built it. So try that and make sure that your lift and you're reducing friction enough. That could be really dragging you down before you start working on your thrust fan. Let's see. Hovercraft kits. I don't have any specific ones. I know Ward's has a nice legal one, but I don't have any specific recommendations. If the floor selected in tournament has some incline, is there a preferred direction? The rules inclined up or inclined down? Well, I try to help the kids out, so I try to have it go downhill if you have to have an incline. Are rechargeable batteries heavier? I don't know. That's a great question. I think I'm going to go down to the basement and measure them later, but you can measure them too. I'm sorry. I just honestly don't know the answer to that question. Can a homemade fan be used as long as it has protection? It would depend on what's in your homemade fan, right? So you can't use any of the disallowed components. You only may use the allowed list of electrical components. So if you can do that with only the allowed components and very clearly only the allowed components, that might be okay. Um, I I would be concerned about that, but it might work. I don't know. I don't know. How do we distribute the weight? Okay, we're going to talk about weights. During different practice runs, the voltage reduces and ends up in inconsistent results. Okay, I think I'm gonna, best place to start building. I think I'm gonna move on and I'm gonna come back and answer some more questions at the end because these are a lot of, I'm seeing this, what do you suggest? And I will try to answer all of these questions. Sometimes it just depends on what your components are and choosing wisely, and making sure they work together, again, and reducing friction and whatnot. So let's move on to skirts because it isn't all batteries and motors in this event. There are other parts that are important. A good skirt minimizes how much lift from the motor you need because the air is well directed and it's not leaking out. And a good skirt conforms or contours with little resistance over any terrain that might be a little bit uneven and returns to its shape. And it actually gives some stability to the craft. Now, there's a lot of online resources about skirt design. It's well worth your time to investigate them, but I'm going to talk about 3 kinds of skirts. So the most common that we see is what is called a bag skirt. And again, you can make a bag skirt with a grocery bag. I used a grocery bag. It is an enclosed bag so it's enclosed all the way down around the bottom of the hovercraft. with many, 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 many little holes. You can use like a pinhole or whatever to direct the air down. So the air is held in that bag and then it's kind of forced out of all those little holes to direct it down. It's a very common, good start, particularly good starter design. If you're new to building a hovercraft, I highly recommend it. It's easy to build. Now there's a little bit higher friction because there's usually some drag, but if you experiment with it, I will tell you, because I had to make several versions of the skirt. I got better at it. I started deciding where the holes needed to go and how big they might be. So kind of playing with it. And if you're just using a plastic bag, you can just get a different plastic bag and try again. But you want to make sure that that bag is tightly taped down around all the edges of your hovercraft so that there's no leakage of air out the top, right? There's also a curtain type skirt. It's also called a wall skirt. And in that case, it's just a single material with no floor underneath it. It's a little trickier to make, but you don't get that friction that you get from a bubble or from a bag skirt, a bubble skirt. It's prone to leaking though, right? Because it can't really very well adjust to the terrain below it. But it's a solid idea and something to try. A more complicated version is something called a finger skirt. That's actually in the picture there of the blue hovercraft. There are these individual U-shaped segments that are actually bag skirts, or like the bubble skirts. And then they're placed around it, and inside it is the inside is open like a curtain type. And that individual bags allows more leeway for adjusting the craft. Now, to answer somebody's question about flexible skirts, a flexible skirt is not required in the rules. There are very specialized hard structure methods to direct the air, and I've seen some, and it can be quite successful. So as long as you can pass the hover test, and again, push up, skitters, whatever, that's fine. So you don't have to use one of these flexible skirts. But skirt, as I said, when I was making it, I was surprised by how important skirt design was in this. The mesh. All right, and we all looked at the mesh on my hovercraft. Don't make this an afterthought. If you have to buy it, if you're buying it, it's also called hardware cloth. You can buy small 1/4 inch sheets on Amazon, and if you're buying 1/4 inch sheets, that's the size of the netting holes. You know that my 3/8 inch dowel will not be able to poke through that. Now, the reason I tell you not to make it an afterthought is because, first of all, it adds weight and it interferes with the airflow, anywhere from like 5 to 20%. So you really want to, so if you've been working without mesh and then it's the night before the tournament, you're like, oh, I got to put some mesh on. And then you show up at the tournament and you're like, why is my hovercraft not behaving right? That's probably why, because it impedes the airflow. Different arrangements can have different impacts. And one thing that you can read about to try to help you design your mesh and how you want to do this, they're called fan shrouds. Now, those are protective frames that are designed to direct the airflow and increase efficiency. But that doesn't just happen just because you made like a little tunnel to direct the airflow. Poorly designed shrouds increase drag. So, you need to ask yourself the question, should the mesh be closer or further away? Does the answer to that depend on which side of the fan is it on? So is it, do you need, if the wire guard is closer to the impeller on the resistance side or on the blowing side, does that matter? So there are answers to all of that out there to help you figure out how you can do this. And I will tell you that some fans, a lot of fans that you can buy already have a protective mesh little wire piece that you can just screw onto the fan. And that's another way you can go. That, those are good too, right? But if yours doesn't have that, then you must have some kind of meshing. Be careful with handling the mesh, sharp edges. You can cut it with scissors. At least the hardware cloth advertises that you can. I found it easier to use like little wire cutters instead. But be careful with your fingers. It's a little sharp. All right, making the craft variable speed. In most hovercraft get down the track end too quickly, by far too quickly. And there's many ways to change that. So some teams, they slow the speed with weights. Now you have to be careful and you have to be clear how you want to do that. Where are you going to put them? Place them in a stable way so you don't unbalance the hovercraft. I've seen teams run their battery down, just stand there holding the hovercraft with it on to run the battery down to a certain voltage to slow it down. Or you can actually use dummy batteries, right? If you have like a battery holder, you could pull out, and put dummy batteries in to reduce the voltage to the motors. You can block the flow of air. So if you have a mesh set up, you can block some of that to impede it and make it go slower. And then some teams use a rheostat or a potentiometer. And if you choose to do that, leave room in your power and weight budget for it. And do know that some motors have a minimum voltage you can't go below. So that would be something also to see in the specs of your motor. So if you use a potentiometer or a rheostat, it may get you part of the way there, but if you have to be really slow, you still might need weights maybe, or some one of these other methods to slow it down. Choosing a potentiometer. A potentiometer or a rheostat is essentially a variable resistor, and it has two parameters that matter. There's the resistance, which is measured in ohms, and that's how much it slows down the electricity. And then there's the power in watts, and that's how much power it can dissipate without burning up. All right. More ohms is not better. The best way to figure it out, we were trying to play with it and figure out, okay, if we use the potentiometer, how many ohms do we need? And so we put a few resistors in our circuit to see how it changed it. And for ours, it showed that it could be really effective in just the 10 to 20 ohm range. So not thousands of ohms or anything like that. And in fact, if you have too many ohms, the knob is going to be too sensitive, right? What that means is that if you move, the motor would go from full speed to zero with just a tiny little turn on the knob. And that's not what you want. You want the turns to actually make kind of, gradual differences in how much voltage it's letting through. But again, you need to make sure that it can handle enough power. And do note the potentiometers that can dissipate enough power tend to be larger and can be a little bit heavy. So it does add weight to your vehicle. So just be aware of that. I'm not saying don't do it, but it can. Propeller torque, or as I like to say, why is my hovercraft always turning into the wall? Or turning in circles, I think somebody else asked in one of the questions I read. The World Hovercraft Organization says that piloting a hovercraft is like driving a wet bar of soap. And what that means is that you slide over most surfaces with little friction, causing the hovercraft to be easily affected by things like, variations in the track surface or the skirt or weight imbalance on the hovercraft. All of these things make your soap bubble lean and move. And also, there's just a built-in problem or challenge, which is that the rotation of the thrust fan, so it's turning and it causes a natural turning force on your hovercraft. So it naturally wants to do that. So you need to be thinking about how to combat that. In the real world, when people ride on and drive hovercrafts, they use pilot lean, which would be essentially weight distribution. So the pilot leans and moves weight over to the other side to offset the desire of the hovercraft to move in one direction. They can use rudders. I have a picture of that up here, of these vertical rudders, the slats that would be behind the fan that can aim the air a slightly different direction to also try to offset that desire or want to turn. I would also encourage you to experiment with using the side of the track to your advantage. You do not have to start the hovercraft in the middle of the track. You could put it up against the wall And there may be ways that you can utilize that bit of support to keep it from turning too. So this is something for you to experiment with, but it's a very real thing. In the tournament that I judged last week, 30% of the hovercraft had only incomplete runs. Actually, we had 60% that had complete runs, but only 30% didn't. And the problem was in every one of them but one, they had plenty of power, but they turned and they got stuck on the wall and just kind of kept driving into the wall. So let's see. Few other construction tips. Plan ahead. Think about where all these components are going to go on your hovercraft. Remember that you have to remove your batteries for impound. Make sure that they're readily accessible, to take out and put back in. So it's especially important if you have I'm sorry, my phone just rang, just trying to deal with that. Make sure that they're readily accessible for you to take out and put back in, because you can't be deconstructing part of your hovercraft to get to the batteries. I saw one kit that had a thrust fan that had the batteries combined in a unit with it. Well, that's all well and good, but once you shield that, you're not going to be able to get to those batteries. So be thinking about things like that as you're constructing. Four hands make some of the construction easier. When we were putting the skirt on our hovercraft, we wanted that to be really tight, really airtight, and having two sets of hands in there was really valuable for that. So partners work together. Again, use the expertise of your circuit lab people. I know that I threw some words like series and parallel out there tonight, watts. Having just enough knowledge about this to help you understand your circuit or have them help you with those parts of it will be really valuable. I encourage two switches if you have two motors. Now, a switch is just, you can buy these little tiny switches just for almost nothing. And you can even do that if you're powering off of one battery. And the reason I encourage that is you're not wasting battery while you're showing the ES that it's levitating, right? You don't have to have the thrust fan and the levitation fan on. And there are a lot of times it felt to me as I've watched students get ready for their runs that they only have one fan on or the other fan on as they're preparing and getting their hovercraft ready to go down the track. Learn some skills in preparation to connect the wires of your craft. And somebody was asking about that. Learn to use wire cutters and strippers properly. Consider learning how to solder. I don't think that is a dangerous skill at all. It just takes a little bit of practice. But if it wigs you out or you don't have access to that, there are also non-soldering connectors available. And all you have to do is Google non-soldering connectors. And as I said, there's these ones you can shrink wrap. Merely twisting wires doesn't make for a solid connection. And I don't encourage only doing that. Though a lot of times you'll need to twist them before you might put electrical tape on them or do other things too. So think a little bit about that. Don't glue wires together. So glue is not a conductor, it is an insulator, and that's not a good solution in this. Some execution tips. Make sure you've got your extra batteries if you're bringing some, and I do encourage it, I think. And know who's going to charge them the night before. Don't expect to leave your batteries charging in impound. There is no guarantee that that can happen. So be sure who's doing what. I've seen too many teams where the students stared at each other and went, I thought you were charging the batteries. I thought you were charging the batteries. Regarding batteries, if you're using 9 volts, pack them carefully so that they don't short out in transit. We had a team that happened to last week. 9 volts are kind of prone to that. You can just put a piece of tape over the terminals and they won't short out in transit. Bring your notes to know how to set up your device for various times. You have to impound those along with the device. And again, as I talked about the bonus, know how sensitive your device is. Have a plan ahead of time. If the bonus is this, or if the target time's this, or if I'm this far away, maybe I would go for the bonus or maybe not. So make a little bit of a plan for that. All right, that's the end of my part of the presentation. I'm going to scroll back through the questions and answers here and see if I can continue to answer them. Can you create an air cushion with no skirt between the hovercraft and the ground? So yes, yes, and that's actually been answered in the FAQs. That's a rule clarification online that says yes, that is allowed. How do we distribute the weight so that the vehicle actually floats when all the components are added? It's a little bit of experimentation, right? I'm not sure I have a great answer for that. And thinking ahead to where you're going to put these components is kind of important. I didn't think enough ahead. The first time I put the components on my hovercraft, I probably made 3 or 4 different skirts just because I hadn't thought ahead enough. But again, I was just making them with plastic garbage bags, so it worked out pretty, grocery bags, so that worked out really well. Where is the best place to start building? Well, I think investigating motors and battery and making a plan for that. And then you need a base. And then I would put your motors on there and make a quick skirt and see how it feels. How is it doing? And then add your switches and then think about your netting and be careful in all of this as you do that. Many of the models you've seen are pretty big and heavy. Have I seen successful builds that use tiny motors and much smaller in overall size and weight? Well, that's what we did with our build. We didn't want a gigantic heavy one. So absolutely, there is no reason this build has to be heavy. You can put one battery for two motors. You can do it with one motor, as I said, though I do think that's pretty tricky. But our battery is powering 2 motors very well. And it's built on a little takeout container, so it's not gigantic at all. You said the blower motor voltage rating should be greater than what is supplied by the battery. I think I said the battery and the voltage and the motor have to be equivalent, have to be rated to work together. So if the battery is limited to 12 volts, I would not encourage you to have an 18-volt motor. I'm not sure that it would support that. Maybe it would. But there are many, many motors out there that are rated for 12 volts. Does it have to be 45 centimeters away from a wall? Or can it just be away from the barrier taller than the hovercraft? Well, the track is 45 centimeters wide. I assume that that's what you're talking about is the track. So when you create up your little track, you need a 45 centimeter width. And do be aware that that's bigger than the allowed width of the hovercraft. So that's intentional for you to have to deal some with the turning and how to work on that. How to vary the blower thrust to control the time taken to cover. You mean the fan thrust to control the time taken to cover the distance? So I talked about, I had a slide about that where I talked about weights and potentiometer and covering the fan, and I talked about several options for that. My skirt hugs my base pretty tightly. Great. And for the most part works pretty well. However, this made the corners of the skirt a bit sharp, and I think it increases friction a bit when it hits the walls. Do I think that's something I should worry about? Well, test it out and see how that works. Yes, the corners were a bit tricky for ours too. We folded carefully, and I'm interested that it's managing still to hold a very tight corner. I would love to see that. If it's working, it's working. So try it up against the wall and the friction and see how it works. If the curtain skirt does not allow the hovercraft to be pushed down and bounce back up, is it legal if I pass a sheet of paper beneath it? You're meaning just for the test, for the touch test to make sure it's levitating? I don't understand how putting a piece of paper underneath it is going to be different from it levitating on a tabletop. So no, you can't add or adjust something to the hovercraft to make it pass the levitation test. It has to pass it under its own oomph. Asking this question again, is it allowed to use a voltmeter to see the volts while adjusting the rheostat during adjustment, not during the run? Yes, absolutely. So if you want to put some kind of banana clips or something on your device so that you can attach a voltmeter to it to see how the voltage is running down. That's actually a pretty common thing that people do as part of their calibrations. And you just have to be able to disconnect it before the run. What happens if the potentiometer starts a spark of fire? So should we use the same one or get a different one? Please get a different one. Please get a different one. I'm guessing that your potentiometer was not rated for the power. Remember, I said that not only do you have to worry about the resistance, but it has to be able to handle the amount of power coming out of a 12-volt battery, and that can be a lot of power. So I'm guessing that was the problem. Please buy a new one. How do you determine the watts you need for your potentiometer? So depends on your battery, and use the power formulas that come in Circuit Lab to help you figure that out, figuring out what your voltage is. And in fact, actually, a lot of times when you buy packs of batteries, it tells you what it is. Any recommendations for rheostats with lower ohms? I found some. It was lower ohms and higher power. There weren't tons and tons of them, but I found some in the like $7, $5, $7 range. I think they were that much. No, maybe it was a little bit more than that. Maybe I'm thinking about how much it weighed. So no, I don't have any specific one. Just get on the 3 sites that I've mentioned, and there are abundantly many others, I'm sure, and look to see if you want a potentiometer or a rheostat. How to place rudders? Well, that's an interesting question. I haven't tried that. I was using weights and playing with weights. The rudders I thought were more challenging, but if you have to have some netting on your vehicle, you already kind of have a thing in place where you can attach rudders to. That would be something for you to try and see what you can do. I'd love to see that design. If we run into the wall, can't we steer it away, or will it get stuck there? You may not touch the hovercraft after it starts over the start line. So no, if it gets stuck there, it gets stuck there. How loose the skirt can be, any considerations? No, but remember, if it's very loose and then it ends up bulging out from underneath the hovercraft, when we measure it, the size of it, it can't suddenly be bigger than 40 by 40 by 40. So take that into account. Is it a good idea to have more holes or a few bigger holes? Well, for my hovercraft, I'm debating about whether I should answer this question because I think maybe you should kind of experiment and see with your own hovercraft. I had kind of a combination. I had some well-placed bigger holes and a lot of little ones. And I think you need to figure out what works right for you. So the way I did it is, I put that plastic bag on there, then I punched a bunch of little holes with a pin, set it down. I'm like, oh, that is not levitating very well. Punched a bunch more, tried it again, made some of those holes bigger. Went, oh, wait, look, there it goes. So, so start small, and you can always add more and bigger holes. And again, you can replace the skirt too. Any tips on keeping the wall skirt tight from leaking? Not any really good ones. It's a challenge. I'm sorry. Yeah, I don't think I have a good tip for that. That's not the kind I used, but it's also a lot of people use it. So I don't have a personal experience tip for that. Sorry. Are slits or holes better to use for a back skirt? I think now it's time for you to go out there and make one and try. What is too fast down the track? I thought the idea was to get down the track in the fastest and safest time. No. I love safest time. No, it's to get close to the target time, and the target times are fairly slow. In Division B, it's 10 to 20 seconds, which can seem kind of fast, but I saw a lot of hovercraft getting down the track in like 4 seconds last Saturday. And then it's 6 to 26 in C. So if you've got a target time of 26, that is really slow. So no, it's not the fastest. So that's what's too fast. We're not allowed to leave it charging during impound because batteries might drain some even though it's charged overnight. I just, it depends on your tournament. Are they willing to have a zillion of you in impound trying to charge batteries on a few outlets? I think you can't be guaranteed that that's going to happen. So don't plan for it. Can I put wheels on the skirt? Underneath it? No, then it's a rolling vehicle. Remind me the height requirement of the dowel. It's in the rules. I think it has to be at 20 centimeters, but look in the rules, please. Uh, can we use a breadboard to create the circuit for one battery and two motors? You may use a plain, breadboard if you really want to, but all the circuit has to be entirely available and open for the event supervisor to view. I honestly don't think that there's any real advantage to doing this here. This is a very simple circuit that you're making. And so I honestly don't think that there's a big advantage to a breadboard. But as long as it's a plain simple one without any um, without any disallowed components in it or on it, you may use one. Can I share the deck, the slide deck? If John gives me a way to do that, but the recording of this will be available, certainly. Is a circular hovercraft a bad design, or does it depend on the skirt design? I don't know. I'm wondering if a circular hovercraft, that whole turning problem, and trying to utilize maybe the wall to help you a little bit rather than harm you. A circular one might not be able to take advantage of having a straight edge. I don't know. It's a really interesting idea. I honestly don't know the answer to that. But I would be interested in knowing what's drawing you to that and what's making you think about that design. I think it's really cool sounding. Does the mesh need to be metal? Is it okay to use plastic netting for mesh? Yeah, I'd be okay with plastic netting for mesh. Is the goal to match the target time or beat the target time? It is to match the target time. It doesn't matter whether you're over it or under it. There's no advantage to being on either side of it. Okay, that looks like we got through all of the nearly 100 questions, John.
Yeah, you did a fantastic job, Karen. So thank you very much for staying a little bit longer. Thank you for those of you that remained. Just to be clear, there will be a recording of all of this. And Karen, if you just want to email me your slides, we'll get them posted up on the website so people can download them if you're comfortable with that. So they have them in addition to the recording. We're going to go ahead and put it up on the Hovercraft pages, the event pages. One last thing before we wrap up tonight, just want to remind you that we have one more of these webinars before we take a nice break for the holidays. Next week, we will be doing solar systems. So if we have any middle school Division B folks out there, please visit the workshop page at soinc.org and you can register for solar system. But if everyone would please thank Karen for doing this and putting this presentation together. It was fantastic, and I always love hearing from you because I always learn so much on what's going on with the event and get some fantastic. I think you gave out some fantastic tips and tricks and things for people to think of. I also would wish everybody a very happy holiday season. I hope for the high schoolers, I'm assuming you guys probably have final exams next week. I wish you all the best on your exams and good luck getting through that. And I hope you all get some time to relax and enjoy family and friends while you're away from school. But otherwise, we have one more webinar next week, and then we will take a break for the holidays. So thank you, everybody, and have a wonderful evening.
See you at tournaments.